Hello. So if you can hear me, just say hi. Say hi by typing where you are joining from in the comment section. Okay, I think not to waste much of our I will start the class now, and I believe everybody can hear me, right? If you can hear me, so sorry for the class not being physical today. So we'll be making it virtual actually, and that's the reason why it's here. So if you can't hear me, just try to type in the comment section, and I'm going to see it from there. Then after the class, I'm going to share a link to this so that you can rewatch. So today class is basically on machine learning, and okay, let me just try to share my screen so that you can see. Okay, can you see my screen? So can you see my screen? If you can see my screen, just okay. Okay, good, good. That's really fine. So I just want to be sure that you can see my screen. Okay. So okay, I'm trying to make this size of this. Okay, I found out these resources to be a very nice one, and I can easily use it for this class. So, as a data science person, you need the knowledge of artificial intelligence, machine learning, and data science. Basically, this is a data science class, right? And you need a good knowledge of machine learning, and this class is actually focused on machine learning. Just a minute. Abeg, una dey talk enter dis thing. Abeg, make una dey talk so. So okay. Hmm. Sorry for sorry for the interruption. I just have to attend to something. Let me reshare my screen. So yeah, this is my screen. So as I was saying, as a data science person, you need a good knowledge of like just like AI, machine learning. But this class is actually focusing on machine learning, and I believe everybody can see what is on the screen, so that because this is basically where I'm going to like do most of my talking, then before I started the real practical section. So artificial intelligence is adaptable, the authors like right now everybody is talking about AI, and as a data science person, you need a good knowledge of AI and machine learning. So, what is AI? Like, what it means? Because we all use AI in our day-to-day activities, like using ChatGPT. People that use ChatGPT, yeah, indirectly using AI because it's like a generative AI, right? There are a lot of things you are using in your day-to-day activities that involve the use of AI that you don't even know. So artificial intelligence and all these things are built. It's just like advanced techniques of machine learning, right? So artificial intelligence is techniques for having a computer or machine think intelligently in the same way that a human brain does. So what it does is like instead of me teaching you, I believe that there's some AI that can teach. There are some AI you all know. If you've not seen robots in the physical, you would have seen it online and everywhere. You see robots performing some certain things, and all these things are done based on data. What is working internally are data. They are fitted with data, and they are responding to some of the data that have been fitted in. So that's like artificial intelligence, the techniques for having a computer do so. So it's just like ability of a computer doing like or machine think intelligently in the same way a woman does. Then this can you see AI is achieved through evaluating the cognitive processes and research the pattern of the human brain. So AI combine of machine learning techniques and deep learning techniques. So AI is built on both machine learning and also deep learning techniques. So these are like two main fundamental that are very essential. And today I'll be taking us through the journey of machine learning. So, what is machine learning? Machine learning is the subset of artificial intelligence that involve the study and the use of algorithm and statistical model in computer system to perform specific tasks without human interaction. So after you training your model, will be training model. So when you train your model will be able to perform some certain things, making some certain prediction without your without manual human interruption or without your interruption. So they should be able to interpret. That's why the person that built OpenAI, that is ChatGPT, is not there. When you ask ChatGPT question, you'll be able to respond. So these are just like these things are built on all this basic knowledge. And machine is divided into two. We have supervised learning. So in supervised learning, you train your model on labeled data, which means we have both raw input data as well as its result. So machine learning is divided into three, but most of the time people talks about two than making it three. They talks about supervised learning and unsupervised learning. So supervised learning work with data that are labeled. That is data that okay, you already know the target variable. So this is what we are like the target variable is already labeled. Why when you are talking about unsupervised learn from pattern. So and the definition I have here is uh, supervised learning. So you train your model on labeled data. That is, supervised learning already understand the kind of data that you are fitting in and the kind of results that is going to produce. But when it comes to unsupervised, and this is just like a perfect example illustration. So okay, data into a training data set and test. So basically they already know the kind of data, they are familiar, like they already know the output, like that is the result, and the data you want to produce they are already labeled. And you can see in this diagram is showing labeled data. This is just like examples of data. You know, data is in different form. The one we've been seeing before, they are number, but data also exists in video, in audio, in shapes, in different form. And in this scenario you see that the label data here is in shapes, right? And the way machine learning works is okay, this is the label data. This data is already known as, can you see the label here? The square, the triangle, and the hexagon. These are just like basic data. That is label. The machine learning model is aware of the names of the data that you are using. That is, it knows the hexagon, it knows the square, it knows the triangle. Then after knowing those names of the data, That is, even if you are fitting it with normal numeric data, he already know, is aware of it. So then after fitting in, you do model training. That is, you train your model to recognize them, although they have a name. It's just like you want to pack a book, and you already know that, okay, you want to pack something, you already know that, okay, this is the name of, but you still need to train like a machine to really identify them without even your interruption, but they already have a name, right? So you do some model training, then after model training you do prediction. This side is for prediction. Then we always divide our data into two parts. We divide our data into training and testing, and the training part is always used to train the model, while you will use the test part to know, to test the model, if the model is performing, if the machine learning model is performing very well. So that's why you will be sure before they release ChatGPT, they would have trained, after training ChatGPT model, that is large language model, they would have tested it several times for them to be sure that this model should be deployed, so that when it gets to the the outside world, there is not going to be giving a wrong answer. So it need to be trained and it need to be tested. So that's why most of the time, and we always divide this into two proportion, that is 70% or 80% training, and then we always use the 20% or 30% for testing. And you can see now, this is the prediction. We already know, he knows here that this is square, and he's predicting square correctly, and he's also predicting triangle correctly. So these are just like the basic ways. Like, this is just showing the pictures of what supervised learning is all about. So the second part of machine learning is unsupervised learning. In unsupervised learning, this work opposite. That is, in unsupervised learning, there is more of unlabeled data. That is, the data are not labeled, and when you work with it, the machine learning model tend to learn from the pattern. That is, saying that, okay, I have similar triangle, I have like maybe many triangle, it's going to group them. We call that clustering. So it's going to cluster the one he find a pattern that look alike. It's going to uh, categorize them, that is, cluster them into a category. Okay, this is triangle, just because he may not name it, but he's going to group them, that, okay, this look alike, this look alike. So he's going to group those that look alike, and we call that just like clustering. So in unsupervised learning, the information used to train is neither classified or non-labeled. That is, they will not have a name. Unsupervised learning study how the system can infer a function to describe a hidden structure from the unlabeled data. The main task of unsupervised learning is to find pattern in the data. That is, it's going to find the pattern, then once a model learns to develop pattern, it can easily predict pattern for any new data set. So in the forms of cluster, the system does not figure out the right output, but it explores the data and draw inference from data to describe hidden structure. So what it just basically mean, that's what I've actually explained in the, so this is it. These are different shapes here. So it's going to learn that, okay, this one look alike, and it's going to cluster them into this category. It's going to also pick another one that look alike. Can you see? This it cluster them into another category, then look at the another one. So you also, so this is, it will be able to predict them, but it's not going to, because they are unlabeled. There's no label on them. He only identify them based on certain structure. So then, okay, somebody was saying, what about WhatsApp chats? AI too. Okay, what the application of AI in WhatsApp chat is, okay, is more of suggestion. That is, when you are typing, there is a technique that suggests, like, is learning. Most of the time when you are type, like, there's a way it can suggest to complete a sentence for you, because it's learning from what you are actually typing. So it's able to suggest what should complete that statement, or at times is going to So it's going to learn from that particular pattern, right? To suggest the other one, and just like in YouTube, for example, too. If you search for something often every time, so the more you search for that thing, it's going to recommend things that are related to that. So all these things are just like based on data. Is based on data. So what is data science? Data science is interdisciplinary field that use scientific method, process algorithm, and system to extract knowledge and insight from structure and unstructured, and apply knowledge and actionable insight from data across a broad range of application domain. So data science is related to data mining, machine learning, and big data. And our main focus now is more of machine learning, and this is one of the typical, like, is very very important in data science. So, and also in AI, but it's just like, if you are more focusing on data science, you have to do more of artificial. If you want to focus on AI, rather, you have to do more of deep learning as well. So you won't just focus on machine learning alone, and you need knowledge of TensorFlow or maybe like PyTorch that we use. Like, you may explore the career of natural language processing, generative AI. You can also work around image recognition. I know that most of us have all these things on our app, like on the phone that we use, especially what is it called? Face recognition. There are some phones that use face recognition. There are some laptop that use face recognition. These are just like basic applications of all these things that we are talking about. But in data science, machine learning is one of the main important things that you need to know. And these are just like some of the skills required, some of the basic computer science, machine learning, statistical mathematics. So you can see that this data science is in the middle, and machine learning is in the middle of all this. So most of the time you need to also have some of this basic knowledge. I think based on our physical class, I've tried to explain some, like basic computer science and all. So these are just like basic things that you need to know to be a good one. And these are like basic applications of artificial intelligence. So I have some of them here. AI in robotics. I believe that most of us have seen robots. So AI is applicable in robotics. Like, most of the things the robot does, like doing a lot of stuff, AI is one of a very crucial part. So AI in robotics, in healthcare, there are some healthcare assistants, there are a lot of things incorporated into healthcare now, also in defense and many other sectors. But these are just like most popular, like robotics, healthcare, and defense. And these are just like so this defense is one of the most crucial sector where artificial intelligence contributing to nation building. Security system can be vulnerable to attack by hackers. These attackers will do so to sell private information, which can prove to be detrimental to any country. This is where the involvement of artificial intelligence proves to be of great use. The analysis of large amount of data become easy with the help of artificial intelligence tools. Powered by AI can find suspicious activities over the systems and keep tracks of the unknown source. So these are just like ways of when, like, the way AI comes in. And I believe robot is kind of common. You can easily ask them. Some can even defend, some can do work, they can do cleaning for you, they can help you to mop floor. There are a lot of things they can do. So far, they are being trained based on data. We also have AI in transport. So in industry has completely changed the area of traveling, as the competition in travel industry is high. So there's a need to analyze all the factors that influence the travel business. So the factors are price, season, festival, the numbers of travelers, etc. With the help of predictive analytics, the software can analyze data related to this factor that impact the cost of transport. So tools powered by AI can perform predictive analytics if efficiently on the data, like predicting the best price in a specific route. Another application of artificial intelligence in transport is route optimization, businesses like Uber and Bolt can use artificial intelligence in their app to show optimized paths, thereby moving consumer faster from point A to point B. So these are just like integrations and applications of AI. We have AI in healthcare, we have AI in marketing, we have AI in automotive industry, we and other use case we have voice assistance. I believe that we've seen voice assistance before. So all these things are applications of AI. We have dynamic pricing, email filtering. I've worked on email filtering before, and this email filtering is just like how your Google email, Gmail rather, is able to filter the one that is spam and the one that is there is a pattern that your Gmail learn from some of this email to be to be able to know that okay, this one has like this one can cause an harm to you. That's why it's classifying them to harm, especially learning from maybe the email. There is money in the email, like the mail. There's things that is looking for it to be able to classify it into harms or spam. So that's just then personalized marketing, process automation, fraud detection. And these are just like basic, I shared something about our project. These are things that you can probably look into. You can do product recommendation, that is recommender system. And if you check YouTube, I think some other guys, few guys have done something. You can just check recommender system, how to build a recommender system. You see some of how to build them. You can make it as a capstone project. Email filtering, I know a lot of people have done it. Personalized marketing, process automation. You may not be able to do this, but you can do customer churn prediction, sentiment, and I've done something regarding the sentiment analysis before as well. So you can do things like that. Fraud detection can be your case study. So these are just like basic things that you need to know as a data scientist, and you just trying to. So I will move to other parts. I think the next page, these are just like basic Python. So I don't think you need all this. So I'm just going to start. Okay, going to talk about introduction to the AI. Okay, so I'm just going to talk about the machine learning development workflow, data gathering, cleaning and preparation, then exploratory data analysis. The reason why I'm jumping some of them is I believe we don't need some, because this is just like a materials for like an AI invasions of a thing. So I just need to just show us some of the things that we need. So okay, now I've talked about machine learning, I've talked about what it means, I've talked about the division, that is supervised and unsupervised. So now I want to talk about machine learning development workflow. So machine learning workflow define the step initiated during a particular machine learning project. So the typical phase include data collection, data pre-processing, data segmentation, model training and refinement, evaluations and deployment to production. So kindly note that the learning workflow vary by project. So, and I would love to tell us, like, just love to re-emphasize it, that machine learning workflow vary by project. So you may have this project just like supervised learning. Now supervised learning is divided into two. We have the aspect of classification model, like we have the part of regression, and these are completely different, because when you are dealing with categorical data, we tend to go with classification side of the machine learning algorithm, and when we are working with regression type, we want to look into continuous data, like in terms of price. So price prediction, home price prediction, you'll be working with a regression model. Why in classification, something in, if your target variable is in category. So this varies based on each project that you are working on, and you need to understand their differences. So this is just like the diagram to explain it. You see, fetch the data is during the data collection part. After fetching the data, you clean the data. After the cleaning, you prepare the data. After preparation, you train the model. Then after the training, you have to evaluate your model to see if your model is performing well. Then after the evaluation, you deploy your model to production. And then after your deployment, you need to monitor your you need to monitor the collect data and evaluate it, so that you won't so that it won't misbehave and you getting what you are not like what you are not meant to get. So this is just like the workflow, so that you need to master when you are working on a machine learning project. So you need to actually look into this. So data collection is one of the most important stage. I've talked about all this before, but I just still want to like use some few minutes to just go over it, so that after this I can go straight to the practical side. And I believe if you don't really understand the basics, it will be hard to follow through when I started doing some of all this coding, like practical aspect of it. So data collection, just like I've explained, data collection is one of the most important stage of machine learning workflow. During data collection, you are defining the potential usefulness and accuracy of your project with the quality of the data you collected. So the quality of your project will depends on the quality of the data you are collecting. Although even if the data is good, you still have to check for anomalies. You need to check for if there is error in your data, and you need to pre-process it or clean it. So to collect data, you need to identify your source. I think I've talked about that before, and aggregate data from those source into a single data set. This could mean streaming data from the internet, download open source data, just like from Kaggle. Kaggle is an open source data, and it's open data that anybody can. There are some data source that you need to buy from. So this Cargo is one of the perfect examples. So constructing a data lake from assorted file, logs, or media. So these are just like various ways of data collection. So then after that, we go into data pre-processing. So once your data is collected, you need to pre-process it. Pre-processing involving cleaning, verifying, and formatting data into a usable data set. If you are collecting data from a single source, this may be a relative straightforward process. But however, if you are aggregating several sources, you need to make sure the data format match, the data is equally reliable, and remove any potential duplicates. So during your data cleaning, these are you need to remove, maybe like if there is duplicate, you have to check the data type, you have to check the qualities, the missing value, a lot of things that comes in place to be sure that this particular data is actually clean. So data segmentation, this phase involve breaking process data into three data sets. So we have training, validation, validating, and testing. But most of the time, people just go with training and testing. So you divided your data into like maybe 70% training. That is, it's just like I'm teaching you something now, and it's just like I'm training you, right? And if I'm giving you test or exam is like I'm testing you. So I'm testing you based on what I've trained you, and I'm trying to evaluate it to see if what I've trained you, you really understand it. That's just like how the concept comes in place. Like training your model, and after training it, you have to evaluate it or test the model with testing part. So 70, it can be 70% training, 20%, 30% testing, or like in your large data set, and it can be 80-20. Then validation can just be 10% at times, or most of the time people don't really do it, but it's a very nice thing to do. So training set used to initially train the algorithm and teach it how to process information. This set define model classification through parameter. Then validation set used to estimate the accuracy of the model. So validation also estimate the accuracy of the model. The data set is used to fine tune model parameter. So test set used to assess the accuracy and performance of the model. This set is meant to expose any issues in the model. So testing will really help you. It's just like if I give you exam now, exam will show if you are learning or you are not learning. That's just how machine learning brains work. So if you are being trained and somebody is testing you and you cannot pass the test, that shows you are not learning. So that's just how it works. So then we have training and refinement. Once you have data set, you are ready to train your model. This involves feeding your training sets to your algorithm so that it can learn appropriate parameter and features used in classification. So these are just like basic things. We also have machine learning evaluation. This is when, after an acceptable set of hyperparameter is found and your model accuracy is optimized, you can test your model. That is testing it to see the performance. Testing use your test data and it is meant to verify that your models are using accurate features. Based on the feedback you receive, you may return to training the model to improve accuracy, adjust output settings. So you need to evaluate your model, your machine learning model, to be sure that it's actually doing very well. So after your evaluation and you are sure the accuracy, you've adjusted it, you are very cool with that, you can deploy it to use so that after deployment, people can consume your uh, most of the time we turn our machine learning model to an API where a software person can build. You will see your ChatGPT, you are not seeing data when you are asking ChatGPT question. You are only asking a front end part and it's responding to you. But what is working internally is like machine learning model. Large, they call that for natural conversational AI, they call it large language model. So then data gathering, cleaning and preparation. Open source data, just like how we've said, like Kaggle is one of the example, but in this place they give different examples of where you can get data. But I will rather advise you to just go to Kaggle. Kaggle has a lot of data set that you can download for free. So in data cleaning part, we have remove irrelevant data, duplicate your data. So deduplicate your data, that is remove any duplicate, deal with missing data, filter out data outliers. Outliers are things that can skew your results. So you have to filter out data outliers, you have to validate your data. That's what you'll be doing in your data cleaning process. So then EDA is just like exploratory data analysis, just like the parts I've thought we've worked on iPhone data before. That's just like working on is working on analyzing, like analysis and visualization of your data. That's what they call EDA, exploratory data analysis. Refer to the critical process of performing initial investigation on your data so as to discover patterns, spot anomalies, test. So basically it's just like the data analysis part and doing some basic visualization. That's just what, and important of performing exploratory data analysis is help you identify error in the data set, give a better understanding of the data set, help detect outliers or anomalous events, helps understand data set variable and relationship among them. So this is just like basic things that EDA will help you to do. That is exploratory data analysis. So I think the last part I will be talking about, this is the core uh, machine learning techniques. I'll be talking about linear regression. Linear regression is one of the techniques in supervised learning. That is, I've talked about, okay, supervised learning is divided into two. We have the classification part and we also have the regression part. So the regression part has like some algorithm. In regression part, we have linear regression, we have cat boost, cat boost regressor. We have different regression model. While in classification, we have support vector machine, we have logistic regression. Okay, logistic regression is under regression, while we have decision tree under classification model. So I will also advise you make some research on, okay, the division of supervised learning, the classification part, some of the algorithm that can work with the classification part, and some of the algorithm that can also work fine with regression model. So what is linear regression, how linear regression works, steps involved in working on a regression model, then other machine learning algorithm. So You can see supervised learning. Supervised learning can be subdivided into regression and classification, just like what I told us before. So it's subdivided into regression and classification. Regressions and classifications are both part of a class of machine learning algorithm called supervised learning algorithm. Remember that machine learning is all about generating future occurrence or predictions of an event while making reference to the past occurrence of the event question. So it can only work based on fitting historical data to make future prediction. And you can see for this we have label. For supervised we have label, just like as I've explained earlier, and these are the label: hexagon, square, training. So after that you fit in this data into this and do some model training and do the prediction. So prediction, then you test it and it's going to give you some of this answer, which is square and triangle. So for classification, a classification classifier model is the type of model in which the output variable, so label. So classification is also label, but it's a discrete. So the regression parts follow continuous data. Why? The classification side follow the discrete. So for example, predict if the pattern has cancer or not, cancer and not cancer. So cancer can be one, why not cancer can be two, or cancer can be zero. And so is in category of cancer and not cancer. That's like classification. So predict if employee will leave or stay. So leave is a category, like leave or stay. So that's like into category. That is into classification side of supervised learning. So leave can be zero, then stay can be one, or one and two. So you can just label it anyhow. So predict email is spam or not. So spam can be one. So this is just like basic category. So you can see in this scenario we have class one and class B. So we also have regression. A regression model is a type of model in which the output variable is continuous. So for example, predict the price of a house of an area, which is the price of a house is always continuous, is not stable. How much rainfall will fall in an area? So rainfall measurement. And this is just like the line of regression, showing the pattern from your prediction. So both similarity between classifications and regression both belong to the class of machine learning algorithm called supervised. Both classifications and regression modeling models belong to supervised learning. So both models a problem by learning a mapping function or relationship from the input X to the output X using node. So property, output or target variable, predict a continuous real value. Regression will predict a continuous real value, while classification will predict a class or discrete value, that is category, maybe category A, B, or category one or two, just like cancer or no cancer, he will stay or leave. But when it comes to okay, learning function, a line of best fit, regression is always a line of best fit in the middle of your data. Just like an example of this red line is a regression line. So predict a class or discrete value, basically still categorical, that is working with classification algorithm. So evaluation metrics, that is loss function. For regression we use mean square error, mean absolute error, root mean square error. Then for classification algorithm we use accuracy, F1 score, area under the curve. So these are just like basic things. I'm almost done with this. So, but I believe that if you don't really understand the basics, it will be hard to really flow along while working on the real data set. So regression is a predictive statistical process where the model attempts to find the important relationship between dependent and independent variable. The goal of a regression algorithm is to predict a continuous number such as sales, incomes, and test score. So most of the time, regression works with price. Most of the time, and price is an example of a continuous data. So first, we have a quick introduction, building. So then we start with linear regression. Linear regression is a best examples of uh, the regression part of machine learning. So linear regression is considered the most natural learning algorithm for modeling data, primarily because it is easy to interpret and model efficiently. For most natural problems, it belongs to the family of linear model or predictor. In machine learning, one of the most useful hypothesis space. So this line is a regression line, and in mathematics we call it, this is just like a straight line equation, y equals to mx plus c. So this is what make this. So it's just like that's just the mathematics behind it. Mx plus c, y equals to mx plus c, and this red line is the linear regression line. So we can see the mathematical theory of linear regression. In linear regression, dependent variable is y, also called the reg- regressor, and the independent variables are set of x, also called the regressor. So this is just like how I said, it's just like m plus, this how they, it's just in terms of working with slope and working with intercept. So y equals to mx plus c basically, but they just write it in another way, but that's just what they really mean by this. You know the intercept, and then you know the slope of your data set. So step involved in working on regression problem. So we have, the first one is importing the required library. Don't let us forget, you have to import the required library, just like we've been doing NumPy, Pandas, Matplotlib. But when it gets to using machine learning, we also use a library called sklearn, that is scikit-learn. We are going to see that as well. So when you import the required library, you also load in the data set. Then step three, you clean the data set. Then you remove the irrelevant data, deduplicate your data, that is remove the duplicate data. Then fix structural error, deal with missing data, filter out data outliers, validate your data, perform data segment, then load your data into the linear regression model. Then train your model, make prediction, evaluate your model. So evaluation is always like, although you may still proceed to do deployment and monitoring your model, but most of the time it always ends here. For a normal project that is not going into production, it always ends at evaluating your model. So if you are following me, on just type in the comment section. Let me see if you are really following me. If you are following me, just say I in the chat section. So I'm checking the chat section. Just say I if you are following me. So I'm waiting to see that. Okay, I can see just one person. So, okay, let me just continue not to waste much of our time. So this is just like the basic steps that will follow. Then other machine learning. The first one I was talking about was the regression, linear regression part, and other part of machine learning is decision tree. I believe that people that this is their first time of hearing this, I believe this is a lot of information already, but just calm down, you will get it. So other machine learning algorithms is decision tree. We have support vector machine. We have XGBoost. Then okay, we also have okay. So building. Okay, let me also just make justice to this. So those are just like basic. So after talking about linear regression, we also have decision tree, we have support vector machine, then we have XGBoost. So I will also talk about supervised learning introduction, or maybe what I'll just do today is like just teach us this basic. Then the next class we can focus on building the real work, or I can also build it today, then the next class will just be like revision, so that we won't need to, so it will just be like revising what I've actually taught you. So supervised learning introduction to regression analysis, so building a predictive modeling, evaluating machine learning model, exporting predictions of machine learning model. So how can you do that? Build a prediction model. So you build machine learning using okay my materials. So this one is even based on exercise, but still yet this is what we'll be doing when you build a machine learning model with a data set. This is just like a sample of data set, but I will not use this. So then we need to evaluate the machine learning model. At times we can use this as a evaluating metrics, r square or adjusted r square, mean square error, mean absolute error. So these are just like basic things. Okay, let me just stop because I think this is just like an exercise. So, and I don't think we need that for now. So I'm going to start my Jupyter notebook. So I'm going to start my Jupyter notebook. Let me check that. So Jupyter. So let me just start my Jupyter notebook. So I'm waiting for it to load. So it's already loading. Okay, now my Jupyter notebook just load and I can see it here. So I'm waiting for the interface to display so that you can all see what I'm actually doing. So okay, this is my own interface. I believe it will be kind of different to our own, but it's still the same thing. So now I'm not going to start a new notebook, but if I'm starting a new notebook, I believe that all of us is something that we are all familiar with. So if I start a new notebook now, I will just write a few lines of code and go back to the main thing. So if I just use print hello world now, print, I don't know all of us the reason why we always like print hello world. So this is just like a normal, but this interface just look different to the one that you are using. But now I already have a data set I want to work with. So let me go to my download folder. So I just go, okay, let me just look for the folder. If the folder is there, oh, I'm not even seeing this. Okay, let me see. I think it's in another folder, right? Let me check. Okay, okay, just give me some minutes to find out where this particular data is about. Okay, okay, let me just look for it on my screen. Okay, let me just put this here. Okay, I think it's already on my. So if I check my desktop now, I should be able to find it. Okay, this is it. So I'm just going to click on this. So in this notebook, I already have the uh, all I actually want to use. I already have them here. But I think for the sake of our time, I will just do a walkthrough here. So after the walkthrough, when we the next class, so that it won't be a lot of information. So I'm just going to just make an overview of it. And okay, let me try to make my screen bigger. Let me check Zoom. Where is Zoom? Okay. Let me just make my okay. So that we can see at least see them. So I'm not going to run them, but this is just basically what is there. So this is the so this is the library that will be working. The first step in machine learning project is importing the necessary libraries that you need, just like pandas. You can see here the first one is pandas, the second one is numpy, the third one is seaborn, the fourth one is matplotlib, the fourth one sklearn.ensemble import random forest, from sklearn.metrics import accuracy score classification report, from sklearn.model_selection import crossvar score, then train test split. So these are like basic libraries that we always use. So I'm still going to make more justice to this next week. So I'll just make a run through. Then by next week, I'm going to start it again. So that next week, but I'm going to give us assignment by like releasing this notebook to us that we can see and practice. So I may even download it like in a PDF format, or let me just release the folder to us, or share the link to this code so that we can just check what is there. So checking it when we come, I think it will be kind of easier, more easier than just. So this is just like the library that we'll be using. You have to, after running the library, like typing the library, you run it. Then this is this data set, but in this scenario we are working with train and test data individually, because this is a competition. So that's why it look this way. But if it is just like a normal, most of the time it's always a single one. But inside that single one, we always split it into training and testing. But this one comes in training part and testing part, because it's a competition data set. And this project is all about Titanic prediction. So what Titanic prediction is all about is like there is an accident, right, which is called Titanic, and they want to write a machine learning algorithm that can predict if people will, maybe a passenger will survive. And this is based on some certain information, like okay, if their name is applicable, you use their name. If their sex is applicable, you use their sex. If their age is applicable, you use it. If ticket is applicable, if the fare is applicable, if the cabin is applicable, if the embark, like what the journey they embark on is applicable, you are going to also use it as well. So this is like basic things that need to be considered before you can predict who will survive or not. And this kind of problem is classification problem. That's why you see categories of 0 and 1. So it is 0 if the person, I think if the person did not survive, it should be 0. But if it is 1, that shows the person survived the Titanic. So and all these things are being based on the information that in terms of sex. Okay, now we can just maybe male student may have the ability to jump or just escape or find ways of escaping from the Titanic, or it's more female that end up dying in the event, just because ladies don't really have that strength or power. So it may be like, is their ticket, the kind of ticket they purchase, it may be in terms of cabin, it may be in terms of the journey they embarked on. So depending on all this scenario will be fitted into this particular. But machine learning only recognize numbers, it does not recognize text. So we need to convert those that are in text to number. And also after that, we need to, you can see NA here, so we need to fill in all this missing value. So that's just so. And this, the test also has the same thing, because we use test to test the model, and the test data does not has a survived, because what we are trying to predict is the survive, that is people that will survive the accident, the Titanic incident. So the second part is checking the shape of your data. So I need to check the shape of the data, that is okay, how many rows, how many column. So in this scenario we have 12 rows, 12 column, and we have 891 rows for training. Then for testing, we have 11 rows, 11 column rather. So if I count it now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 column, then we have 418 rows. So that's just it. So I'm trying to check the shape, and this is how to check the shape. So the training dot shape, then the test dot shape. So we also try to do some basic data exploration. So checking the information of the data for me to see the data type. If the data type is right or wrong, that I need to check. I need to change. I believe this one is not new to us. We did this in using the iPhone data, like the integer, the object, the float. So these are just like basic data type of these features, and if it is not right, we can easily change it or make an adjustment to it. So also checking for the second one, D type, so we can see all their data type, and also checking the missing value here. You can see some of them have missing value while some does not. So we can also check the describe of your data by checking the count, like the total count. You can see here that we have the count of 990, 891, 891 for survivor, P class 891, but when it comes to age, we have 714. So that shows age has a missing value, and we need to fill it. This is the mean for all this particular column, and this is their standard deviation, this is their mean, this is their minimum, this is their 25 percentile, 50 percentile, 75 percentile, then this is the maximum. So these are just like basic, like I'm just trying to understand what is going on in my data, right? So you can see this includes 7/12, showing that 5 other column are categorical variable count, shows how many rows have non-missing value. So this, the mean calculate the average standard deviation. So this is just like a basic note of okay, what is going on. Like you can see here, age has 714. That is not the same, like the account is not the same. So some values are missing in age, and we need to take care of that. So now we are now using training dot is null dot sum, that is to check the missing value, like the total missing value. And you can see for passenger ID we have 000, then when it get to age we have 177, that is the missing value. From the cabin we have 687, then embarked we have 2. So this is like the missing value here. So this is the missing value here. So for testing as well, we have this as, but in some scenario you don't need to bother about this. So it may just be like a single data, but just because this is a competition data set, that's why it has both training and testing separately. So we consider missing value. There are several ways to take care of them, and these are the ways. Missing value equals to train underscore df dot is null, then dot sum. So this is like anyone that the missing value is greater than 0. So we have age to be 177, cabin to be 687, then embarked, which is 2. So these are just like basic missing value. Then the age average is this. So we now try to use the average age in the column to fill in the missing value. So and this is just like the sample code for doing that, which is the average. I'm just trying to check it, which is the average of the age is 29 point something. So in which 29 years old is the average age in that particular data set. Then I also try to check for the test, which is 30 years, then try to fill in. So for cabin, just because it's test, I'm trying to fill the missing value with unknown. So because it's test, it's not number, so you can't calculate anything. So I'm filling the missing age with the average age in our column, so which is 29 for training and 30 for testing. So I'm filling uh unknown for cabin because it's text. Then for embark as well, I try to count this to know exactly what I can do. So because they have the numbers of, this is the three categories in embarked. Six S has 4 4, while C has 168, Q has 77. So train dot fill embark. So I try to fill in with mode, that is the one that is more, that the modal class here is S, so S has more stuff. So I try to fill in with that, then do some data visualization. So I use cant plot, SNN dot cant plot data equals to train x train. Then I try to check the distribution of survived, that is people that they are able to survive and those that are not. So this is the plot showing that here. So and also I checked that like mathematically to just give me the exact percentage, so that I will be sure the percentage of my the people that survive and people that does not, like that did not eventually survive in the Titanic. So I have 61.6, then 38.4. So these are just like, so for me to know the distributions before making my prediction. So I also try to use this, which is like normal distribution, to be able to know. I'm just doing this to question my data and be sure of what is going on. So I also try to make some adjustments to for the age, then try to do some visualization of the age to see the distribution as well. And using histogram, and this is the source code for doing that. Then I also did for fair. This is for fair. You can see that this one is not evenly distributed because it should look like a bell shape, I mean a dumbbell shape. So data column, these are the data column for the gender. We have for female and we have for male. So we are trying to check the survival rate of males and female. So people that survive for female and people that eventually not survive. So trying to check the distribution here. So and also try to check the survival rate here as well. So this is just basic things I'm trying to do. Then okay. So I also try to make some visuals on patch. I'm picking those column one after the other to see what is actually going on there. So also I try to check on embark and see, okay, this is the percentage of survivor and people that were not able to survive based on uh embarked features. So I also use heatmap after using, I also check P class to see the classes that survive more and the one that does not. So I'm just trying to check before making my prediction. So this is for heatmap. This is how heatmap look like. To check, heatmap is basically used for correlation score. So that's what we did here. Then handling category column. So these are the category column because machine learning only understand number. So we need to change this text, everything to a number. And how we can do that is by using, we can code it ourselves and we can also use label encoder. Label encoder is like a process, like just what is it called? It's like a library that help you to change text to number. So I try to use label encoder to change my text to number. That's what I'm using fit transform here. So that's just basic things I'm trying to do with this code. Then dropping unnecessary column. I also try to drop unnecessary column. So the unnecessary column here is name and passenger. Passenger and names does not contribute to my model and does not really make my model look better. So that's why I'm trying to drop them. Then also now, this is the source code for doing that. Then we also need to build the machine learning model, because what I'm trying to do since is just like exploratory data analysis, like trying to check in what is going on in my data set. So I will end this soon. So I'm almost done. So I have for my training data set, I have to divide it into X and Y. Y is my survivor, my survived, like the survived column, while the other part is my X, that is my X is depending on Y. So I think I would stop here because of this rain, because it's going to be causing interference. But let me just make like a run through. So my x is depending on my y is just survived column, and the x is the one that y is depending on. So I first use random forest classifier here, just like my algorithm. That's what I use. This is how to place of a random forest classifier, and this is how to check the correlation score, the accuracy, to know that this model is actually performing well. And the first percentage is 82%, and the second one is also 82, 75%, 87. This is just like me testing the performance of my algorithm to really see the one that is making sense and the one I can easily use. So I have to also split it into training and validating. So this is how to do that. And I try to make prediction. So my prediction accuracy score is 82%. And this is also classification performance report. So we have precision, recall, F1 score. All these things are still something that I'm still going to explain later when we meet. And also I did features important. This will show how important each features are in my data set. So I think this is the best place to stop. So thanks for staying through. Goodbye for now. We meet next week. So bye for now.